Welcome students on the third video for the topic role of sensors and actuator in IoT. In this video, we are going to discuss sensors, actuators, their role and the different type of sensors and actuators and how they are classified. Myself, Smita Chaudhary. Before starting with the actual topic of sensors and actuators, let's take an example of a self-driving car. I think we know one of the well-known example of a self-driving car as a Google car. Now this type of a car are going to have many type of sensors which build an ecosystem of a sensor which provides a very interesting data. Here we are going to list out what these sensors are going to provide us. So they provide us a great amount of data that can be integrated, consumed by a variety of systems. We can have the services on the car itself as well as shared externally with the other vehicle. I can share variable data with the use of this sensor with the other vehicle also, so that it will be helpful for me for getting any kind of a help if it is needed. The connected roadway infrastructure. I can connect my internal gateway system of the sensors with the roadway infrastructure also. It is also useful for saving the data on the cloud-based diagnosis, as well as it is going to give me the different type of consumer services also. So the data which I am going to get from the sensors which are inbuilt in the vehicle, I am going to utilize that kind of a data for the different type of the decision making, also to get the actual condition of the vehicle. So almost everything in the car can be checked and can be controlled. Remember that I can check all the things remotely, either sitting inside the car or being outside the car also, as well as not only check but I can control the things also. So the car is filled up with all the type of sensor which is going to help me to get the actual condition of the car. So we have seen that the car is filled with different type of sensors. Now what can be those sensors? The sensors will be the temperature sensor, the location sensor, for example GPS, pressure sensor and velocity sensor. So the data which I am going to get from these kind of the devices will be the relevant data which will be rich in a way and amount of many type of things I am going to get from this one. So what I am going to achieve with this data? With this data I am going to improve the safety. I am going to simplify the vehicle maintenance. I am going to enhance the driver experience. So with the help of these kind of a sensor network which is there inside the smart car, I can achieve these many of the things. Now such sensors are going to be the fundamental building blocks of the IoT network. They are the fundamental element found in a smart object, the thing in a Internet of Things. What we always talk about, the thing in the Internet of Things. Now I have just said one word, what called as a smart object. So what is a smart object? A smart object are any physical object that can contain an embedded technology to sense as well as to interact with their environment in a meaningful way by being interconnected and enabling a communication among themselves or an external agent. So likewise, we have seen an example of a smart car which have the inbuilt sensors, embedded technology which is going to help it to sense, to interact with the environment of a car, as well as we can interconnect it and communicate with the use of the sensors. Now we have talked a lot about the sensors. Let's see what is meant by exactly a sensor. So sensor does exactly as its name indicates. It senses. It senses. So it senses. A sensor measures some physical quantity and it converts that measured reading into the digital representation. That digital representation is typically passed to another device for transformation into useful data that can be consumed by intelligent devices or even by the humans also. So naturally, I can draw a parallel can be drawn with a human and where the human uses their 5 senses to learn about their different surroundings. So human senses do not operate independently in Seoul. We know that the one who controls the human senses is nothing but our brain. So they complement each other. The human senses complement each other, compete together, empowering the human brain to make intelligent decisions. So the brain is the ultimate decision maker, and it often uses several sources of the sensory input to validate an event, compensate for the incomplete information. So sensors are not limited to a human-like sensory data. They can measure anything worth which is measurable. Sensors provide a superhuman sensory capability which is going to help us to build the data as well as to sense the fruitful information. So sensors can readily embedded in any of the physical objects that are easily connected to the internet by wired or a wireless network. We have seen the Google car where the data is going to be passed to the cloud by using any kind of the wireless network technology. So connecting a sensor devices in this way has the user in a world of a IoT and a whole new paradigm of a business intelligence. So connecting a sensing device is going to help us to get many kind of the information. Now we have just seen the sensors. What is mean by that? Let's see what are the different type of a sensor which are available. So there are countless different sensors available to measure the virtually and everything in a physical world. There are number of ways of classifying these kind of a sensors. Either we can group them, we can cluster them in a different categories. So here the one way of classifying the sensors which is presented in this book. The first type as active or passive sensors. Sensors can be categorized based on whether they produce an energy out of and typically require an external power supply which is of the type active. So active sensors requires an external power source to operate such as GPS and radar. Then comes the passive sensors. So passive sensors generate their own electric signal and do not require any external power sources, exactly opposite to that of the active sensors. These include the thermal sensor, electric field sensor, sensing and a metal detection. Let's see the one more category, that is invasive and non-invasive. Sensors can be categorized based on whether the sensor is a part of the environment it is measuring. That is whether they are internal or external to it. So depending upon that, I can also categorize the sensors. The next one as contact or no contact. Sensors can be categorized based on whether they require a physical contact with what they are measuring. That is contact or no contact. Contact sensors include temperature, strain gauge sensors, and no contact sensors include optical and magnetic sensors. The next type as the absolute or the relative sensor. Sensors can be categorized based on whether they measure on an absolute scale or based on a difference with a fixed or a variable reference value. So depending upon the way they are going to measure the things, I can categorize them as absolute or a relative one. So absolute is nothing but a thermistor and relative is nothing but a thermocouple. I can classify the sensor depending upon the area of the applications. Again, I can classify them how the sensors are going to measure. So sensor can be categorized based on the physical mechanism used to measure the sensor inputs. For example, the thermoelectric, thermochemical, optic, electrofluid mechanics and the photoelastic sensors. The next one as what the sensor measures. So sensors can be categorized based on their application or what physical variable they measure. So these are the number of ways. So there are many other classification and taxonomic schemes for categorizing the sensor, but I can have included the sum. I can also categorize them depending upon the material, cost, design and so many other factors. But the most useful classification scheme for the pragmatic application of the sensor in IoT networks is described in the next slide that we are going to see. The next one as the classification of the sensors as So here I have categorized the sensor as depending upon the position. A position measures the position of an object. So for example, which includes the proximity sensor. The next one as the motion sensor. So occupancy sensor detect the presence of a people or animal in the surrounding. For example, a radar. Velocity and acceleration. So velocity nothing but the speed of motion of a sensor, may be a linear or angular also. So if I'm using it for measuring that one, so depending upon that also I can categorize them. So acceleration sensor measure the change in a velocity. So that includes the accelerometer present on our vehicle. The next one has the force. So force sensor detect whether a physical force is applied or whether the magnitude of the force is beyond the threshold. So that is nothing but the force gauge. Then a pressure sensor. Pressure sensors are related to force sensor and measuring a force applied by the liquid or the gases. For example, a barometer. Next one as the flow sensor. Flow sensor detect the rate of the fluid flow. They measure the volume or the rate of the fluid that passes through a system. For example, a mass flow measure or a water meter, which are normally installed in our houses. The next one as the acoustic sensor. Acoustic sensor measure the sound level and convert that information into digital or analog signal. For example, microphone currently which I am using. The next one as the humidity sensor detects the humidity in the air or in a mass. So normally its applications in measuring the humidity of the soil. For example, agriculture application. So soil moisture sensor. Light sensor. Light sensor detect the pressure of the light. So it is an infrared sensor or photo detector. Normally you will find such kind of a sensors in a smart home also, where I want to control the light of the room. The next one as the radiation sensor. Radiation sensor detects the radiation in the environment. The next one as the temperature sensor. I think you know the thermometer. Chemical sensor measure the concentration of a chemical in a system. For example, CO2 sensor senses only carbon dioxide. So I can use such kind of a sensor for detecting the smoke. Normally, you will see such kind of a sensor which are installed in a hotel where they use for detecting the smoke. The next one as the biosensor. Biosensor detects the various biological elements such as organism, tissue, cells. For example, the blood glucose. So this is the one more way of categorizing the sensor along with their examples. Now, after discussing the type of sensor, let's see the one example, the one application of the sensor in agriculture. That is a smart, we can say a smart agriculture, or we can also call it as a precision agriculture. So the sensor, as we say, know that the sensor can come in any shapes and the sizes also. We can use them for measuring, just we have seen the table where we have seen the application where they have used for measuring the physical condition. Now, in agriculture, we use a variety of technical advantages to improve the efficiency, then sustainability of the farming practices. Now, this includes the use of GPS, satellite aeration mission for detecting the field viability. Again, we can go for using a robot for high precision planting, harvesting, and irrigation also. In a real-time analytics and artificial intelligence to predict the optical crop yield and the weather impact on the soil quality. So these are the applications area where we are going to use these sensors for going towards the smart agriculture. Now, among the most significant impacts of the precision agriculture are those dealing with the sensor measurement of variety of soil characteristics. I can go for using the real-time measurement of a soil quality, pH level, toxicity level. Also, these all data is going to help me to find out the levels of the different parameters of the soil. Again, it is going to help me to decide what kind of a planting I should go for in a next coming year. Again, this is going to help me to find out the nutrient level for fertilizing the planting. So depending upon the values which I have received from this system, I am going to do the fertilization of my crop, and this is ultimately going to increase the productivity of my land. So all these detailed sensors are going to be useful for me to boost the productivity and to boost the crop productivity also. In the last segment of the video, we have discussed the application of the sensor in the agriculture. But the one application of the sensor which is present all over us is nothing but the application of sensor in a smartphone. The most significant accelerator of the sensor deployed in a smartphone. More than billions of smartphones are sold each year, and each one has well over dozens of sensors inside it. So you can imagine the number of data, the volume of the data which is generated by using these sensors. Again, we can have the different sensors which are installed in our smart home, which converts our home to smart home. We can have the hundreds of sensors which are installed inside the vehicle, which call a car as a smart car. We can have the sensors which are going to connect the different two cities to build the sensor network. Here you can see the application of the sensor or the different sensors which are present in our smartphone in the format of GPS, light sensor, touch screen, fingerprint sensor, microphone, and so on. Now, after discussing the sensor, it's time to discuss the reverse of that one, and that is what's called as the actuator. So, actuators are natural complements of a sensor. So for discussing these two types which are opposite, symmetry as well as complementary of nature of each one, we need to discuss what is. We have seen the sensor, but let's see it one more time. So sensors are designed to sense and measure practically any measurable variable in the physical world. They convert their measurement into an electrical signal or the digital representation that can be consumed by the intelligent agent, whereas the actuator receives some type of a control signal that trigger a physical effect, usually some type of a motion or the force. So that's why it is said that they are exactly opposite to each other. I think this diagram clears the thing in more. The sensors and actuators interact with the physical world. You can see the real world or the physical environment, which is sensed by the sensor and converted, which is made into the electrical signal, either a digital representation or the electrical signal. In opposite, actuator acts to this digital signal and produces or do the useful work on that one. So that is what the sensors and the actuator. In the previous slide only, we have seen the parallel thing of the sensors and the human being. Let's see again the comparison of the sensors and actuators functionality with the humans. Now, human uses their 5 senses to sense and measure their environment. Now, the sensory organ convert the sensory information into the pulses, that is electrical pulses, that the nervous system send to the brain for the processing. So the data which is sensed by the sensors, by our 5 senses, is going to be sent by the nervous system to our brain. Now, likewise, the IoT sensors are the device that senses and measure the physical world and signal their measurement as an electrical signal to the some type of a processor or the controller for the additional processing. Now the human brain signal the motor function and the movement, and the nervous system carries that information to the appropriate part of the muscular system. For example, maybe hand or maybe our feet. Whereas the processor can send an electrical signal to an actuator that translates the signal into some type of a movement. For example, a linear movement, a rotational movement, or useful work that changes or has a measurable impact on the physical world. So this interaction between the sensor, actuator and the processor and the similar functionality is in the biological system is the basis of the various technological fields, which includes the robotics and the biometrics. Now we have seen the classification of the sensors, but the actuators are also vary greatly in function, size and the design. Some common ways by which I can classify the actuator as, the first one as the type of motion. So actuator can be classified based on the type of motion they produce. For example, linear motion, rotary motion, 1, 2, 3 axis motion. Power actuators. The actuator can be classified based on their power output. For example, high power output, low power output, or a micro power output. Another way of classifying the actuator as a binary or a continuous actuator. So actuator can be classified based on the number of stable state output. How many number of stable state output it produces. Depending upon that also, I can classify it as a binary one, or if it is producing the continuous output, it is producing the continuous movement of the one of the rotary, then I can say that it's a continuous actuator. Again, I can classify it depending upon the area of application. So actuator can be classified based on the specific industry or the verticals where they are used. The next one as the type of energy. So actuator can be classified based on their energy type. So these were some of the common way of classifying the or categorizing actuators. So categorizing actuator is a quite complex way of doing this one. But the most common used classification is based on the energy type. Okay. So let's see the type by which I can classify the actuator based on the energy type. So it is as the type as the mechanical actuator. For example, a lever, a screw jack. I'm classifying the actuator based on the energy type. The next one as the electrical actuator, which is nothing but the thyristor, a bipolar transistor, a diode. The next one as the electromechanical actuator. For example, AC motor, DC motor, step motor. The next one as the electromagnetic actuator. For example, electromagnetic or a linear solenoid. Then a hydraulic actuator, a hydraulic cylinder as an example, or an air motor. The next one as the smart material actuator. Nothing but the one as the ion exchange fluid, and the next one as the micro nano actuator. Okay. So these are the way of classifying the actuator based on their energy type. Now in this segment of the video, I am going to discuss one of the most interesting topic, and that is a micro-electro-mechanical system. Now one of the most interesting advantage in a sensors and actuator technology is in how they are packaged and deployed. Now microelectronic mechanical systems, sometimes simply referred to as a micro machines, can integrate and combine electric and mechanical elements such as sensors, because sensor electric, actuators can be considered as a mechanical element, on a very small scale, for example in a millimeter or even on a less scale also. Now one of the key of this technology is a microfabrication technique that is similar to what is used for microelectronic integrated circuits. Now this approach allows mass production at a very low cost. Now the combination of a tiny size and a low cost and the ability of a mass production makes MEMS an attractive option for a large number of IoT applications, because I can develop an IoT application with a very low cost, and if it is developed at a low cost, then it is going to reach to maximum number of the people, and that's why I think that makes the IoT to be that much popular. So MEMS devices has already been widely used in a variety of different applications and can be found in a very familiar everyday devices. You will shock to see the list or the examples of MEMS which is existing in our world. The best example which we use as the inkjet printer, which uses a micro pump as a MEMS, which that means it converts the both thing in a one place. For example, the electric as well as the mechanical things in a one place. Then a smartphone also has a MEMS technology for the things like accelerometer and the gyroscope. In fact, the automobiles were among the first is commercially introduced in MEMS into the mass market with the airbag accelerometer. Now, MEMS, as said, is only few hundreds of a micrometer across, and a scanning electron microscope is needed to show the level of detail which is present in that one. Now, a microscale sensors and actuators are immediately embedded in an everyday object. So, which is a defining characteristic of the IoT. So, this makes the IoT as one of the significant thing to reduce its own cost. And that is what to be expected for the IoT. I have taken the reference from the book IoT Fundamentals, Network Technologies, Protocols and Use Case for IoT, that is Internet of Things, by David Gonzola, Patrick Cisco Press. Thank you for listening.